Hello and welcome back once again. So here we are in the very last video for the parser implementation, and once we get through with this video we will have completely written a parser by hand. Now there's one last thing that needs to be added in, and Nelson kind of stumbled on it in the last video. It was just something that was, well, forgotten about. So you may have caught it if you listened very carefully as he was implementing the test of the whole bunch of stuff, and he started to enter in a very specific color. A very specific format for the color, to be more precise. Correct, Nelson?
Yeah, so we need to parse colors. And parsing colors is actually going to be an interesting problem, which we'll get into in a moment. But first I want to go ahead and write the test just to show you guys the format of all the colors that I'm going to accept with CGS. And these are also the format of colors accepted with CSS. So I'm going to go ahead and I'm going to put this name at the top. And I'm going to say, the first test I'm going to do is parser given RGB color. And so I'll have a test property with the first format, RGB, followed by numbers, three numbers from 0 to 255.
Okay.
Now we'll need to match it against a color value, which we have not implemented yet. And you'll notice that I'm passing in an additional parameter to my color value. That's the alpha, which brings us into the next format that CSS supports, which is RGBA. It's an RGBA followed by a, well, it's the same thing, basically. I'm going to make these tests a little bit nicer, though. This is going to be 101, 102, and 103.
Nice.
Just so that we can make sure that it's not mixing up our colors.
Sure.
And there. Next format of colors that are supported in CSS are going to be named colors. So we can do red, for example. And then we'll do given named color. And the named color is going to be parsed, or going to be, the red obviously is going to be 255.00255. So that's 255 on the red channel, 0 on the blue and green, and 255 on the alpha channel. The next format that it supports is going to be three hex values, 3 nibbles. So given 3 nibbles, and that's going to be, we're going to do red again. So let's do F00, which should be the same color value. The next one is 6 nibbles. And so we'll do, I'll just do white because I don't want to calculate that out. So yeah, so now these are all the formats that we're going to support. And so we need to figure out what the most effective way to support them will be. I'm not going to worry about the nibbles yet because that introduces the interesting problem I was referring to. Let's go ahead and start with, I think, the simplest one, which is just going to be RGB. The first thing I'm going to do is implement our color value object, and he is going to be an I value. And his property type is going to be a color, which we put in the enum but never implemented for some reason. And he's going to take an RGBA value. And these are all going to be private set. And we're going to go ahead and implement our quality members. So same stuff with all the other values. Resharper just generated a bunch of boilerplate code that essentially says this value is equivalent to another value if all the properties are similar. Or equivalent, not similar.
Yeah.
And then I'll just go ahead and implement the 2 strings so we get a nice little thing. I mean, I guess we could just do GBA just to make it more concise. Okay. So here is our color value. We're going to be coming back to this because we need some more functionality soon. But for now, we can implement RGB and RGBA. And like I said, this is the simplest format. So if we go into our parser, we're going to basically hijack the code that the resource used. Because basically what's going to happen is the Lexer is going to turn this into an identifier token. So all we need to do is say, okay, are we sitting on an identifier token, and is the next token a open parenthesis? And if it is, we're parsing a color. So let's go ahead and say else if identifier equals RGB with a invariant culture ignore case, and the next token dot type is a what was it, operen, then we are going to parse this out. And this code is going to look a little bit ugly. It's kind of brute force, but it's also very straightforward. The first thing we're going to do is match that operen away. We don't need it anymore. Then we're going to say var red equals int.parse, using int.parse on purpose because it will throw an exception if they stuck a decimal, which is invalid. Look ahead one.text. Then we're going to match out that number, make that number go away. Of course, you're not going to. And then we're going to match out our comma. Then we're going to do green. Int.parse look ahead one text. Match out our number. We don't want that anymore. Match out our comma. We don't want that. And then we need our blue. Look ahead one.text. And then finally we're going to match out our number. And then we're going to match out our cparen. Finally, at the end of it, we'll do values.add new number, or sorry, color value, and then we'll pass in red, green, blue, and 255. So sweet. And then just because we're here, I might as well just copy and paste, add a, and instead of we parse out our number, and then we match out a comma, and then we pull out our alpha channel, and then we hit page up a few times. And yeah, then we go and we match out our number. And we replace the 255 with alpha. Okay, so RGB and RGBA should be supported. Let's see how the tests do. So let's do these two tests and run them.
Awesome.
Sweet. And so you see that's all being printed properly.
Mm-hmm.
Okay, so the next thing we need to do, I'm going to worry about named colors. Now, named colors, in the CSS specification, there is a large set of named colors, and we're going to support all of them. So let's go into our color value. What I'm going to do is I'm going to write a enum called color constant, and this is going to have all of the names that are supported for our CGS parser or CSS parser, whatever, which is black, silver, gray, white, maroon, red, purple, fuchsia, green, lime, olive, yellow, navy, blue, teal, and aqua. Do we have white in there? Yeah, we have white. Okay, good. So here are all the color constants that we're going to support. Now, inside my color value, what I'm going to do is write up a little public static color value from name method. That's going to try to parse this name against the enumeration, and if it does, it will return a new color value based off of a dictionary I'm going to stick up here. So it's going to be a private read-only dictionary with the key of color constant and a value of color value. And I'm going to call this color constants. I'm just going to initialize it inline, bring out our dictionary initialization syntax, and start a lot of typing. A lot of typing. I mean, yeah.
If you got it to copy and paste and they can pause it, you can just go ahead and do that.
And no, I got this. Okay, well, let's start with this. Da, 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 da. I mean, you have to support this, especially like white, black, blue, and red and yellow.
Yeah.
I use those so often. I had no idea that fuchsia was a color constant until I read the spec. That was kind of weird. You don't really think of that as a standard color. Oh, look, I was right on track. Okay, so let's go ahead, and I should have probably included this in my copy and paste. So this is how Nelson copies and pastes lots of code and fails miserably at it. I don't really care about the formatting resharp. I'll take care of that in a sec once I close the last brace. Okay, so now if you ever wondered what these values were, if you're a CSS developer, I'm going to type them all in now. Black is obviously 0. Silver is going to be 192 on everything. Gray is going to be 128 on everything. And of course, I screwed up the alpha channel. I'll fix that in a sec. White's going to be, well, 255 on everything. Maroon is going to be 128 on red and 0 on everything else. So 128. Red is going to be, well, 255 on red and 0 on everything else. Purple is going to be 128 on blue and red. So purple is going to be 128 on blue and red. And fuchsia is going to be 255 on red and blue and 0 on green. Fuchsia is going to be 255 on red and blue. And green is going to be, well, pretty obvious. 0, 0, 255. And then lime is going to be green of, or actually, this is the funny thing. Green is actually 128 on green. And then lime is 255. I thought that was kind of interesting.
Mm-hmm.
So, hey, you guys learned something. Olive is 128 on red and green. 128. 128. Yellow is 255 on red and green. Yellow is 255 on red and green. Navy is 128 on blue. Navy is, don't know my alphabet, 128 on blue. Blue is 255 on blue, obviously. Teal is 128 on blue and green. 128 on 8 on blue and green. And aqua is 255 on blue and green.
At the top.
255, 255. So the only thing with all zeros should be black. Good. Okay, let me go ahead and fix my alpha channel, and that was officially the most boring part of this entire series. Okay. Okay, so now we have our color constants, our from name. What it's going to do is it's going to use the enum.tryparse method, and I'm going to put a color constant right here. I'm going to say if enum.tryparse name ignore case and then out constant, then go ahead and return. Really, did I not make that static? No, I didn't make this guy static. Go ahead and return color constants with the constant. Otherwise, go ahead and return null. I'm going to also rename this. So it's now color constants with a capital C. Okay, so there's our from name method. So now what we need to do is we need to go into our identifier parsing code which is right here. And if it wasn't matched, if it is an actual identifier, we want to see if it's a color first. So we'll say var possible color equals color value dot from name identifier. If possible color is not null, then say values add possible color. Otherwise, just go ahead and add it as an identifier. Okay, so that all builds. So let's go ahead and see what happens when, and we get success.
Nice.
So if I run everything,
Woohoo.
nice. We might have broken something, which is kind of cool.
Gotta love unit tests.
Yeah, so what did we break? Expected true because border bottom was expected, found border bottom black. That is black. Are you stupid? I'll figure that after we fix the hex. I think there's something wrong with my color value object, but I don't want to play with that until we get the hex parsing code in there.
Okay.
So now this is the interesting thing. This is one of the biggest reasons why I wanted to do this little mini, write parser by hand course before going into Antler, because you really need to understand the relationship between a lexer and a parser. That's not really all that apparent using Antler because you usually define both of them within the same grammar file. But with this, we actually saw them as two distinct classes with two sets of responsibilities. Now, the problem is the lexer really has no way to reliably determine if this is a color or if it's a part of an ID selector. So if we look down here, you'll see an ID selector also has that syntax. So you have a few options right here. You could do what we're doing right now, where we parse out the hash as its own token, but then different IDs will be, or different colors will not work properly because you won't have anything to identify a hex color as, because it could be anything from this, which would be this would be lexed as an identifier. There's no way for the lexer to know any different. This, which is also a valid hex color, would be parsed as a number. This would be parsed as an error, or lexed as an error. So there's really no way to do this cleanly. So what I came up with was I'm just going to change the definition of my hash token to include any numbers or letters, any numbers, letters, dashes, or underscores after it, before any white space or any other tokens. So then I'm just going to reuse that hash token when I'm parsing out a ID. So that makes sense?
Mm-hmm.
So let's jump into our parser, our lexer. First thing I'm going to do is I'm going to nuke this. We're no longer lexing that as an individual token. Instead, what we're going to do is add another set of predict and parse methods. So we'll say if predict hash return parse hash. Predict hash is just going to return character is a hash symbol, and parse hash is going to do a lot of fun stuff. Actually, not really. It's kind of boring. And we're going to, just to be consistent, we're going to move that there. We're going to move this to the bottom. So the parse hash is really just going to be a special type of identifier, I guess. That's more inclusive. So we're going to start at the pointer. We're going to match out the hash. Then we're going to say, while we are not in white space, and we're not at the end of the stream, and we are either in the valid identifier prediction or in a valid number prediction, then consume. Finally, return create token with a type of hash, a start of start, and an end of pointer -1. So this will parse out the entire thing with including the hash symbol at the beginning. So let's go ahead and run our lexer tests again, see what happens. Okay, so this is good actually. So our lexer right here is failing because it's expecting a hash then an identifier. If instead I just said a hash with this text, then this test should pass. Yeah, blah, 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 blah. The hash is included. And we get success. Finally, I'm going to add another lexer test. I'm going to say, actually, I'm going to put this near the top because it's kind of one of the main ones. Actually, I'm just going to copy and paste this. Why not? Lexer given string with hashes returns hash tokens. And I'm just going to hash all these guys up. And I'm also going to say, hash with the 0 or in the 00f, for example, which are valid hashes. And then so we're going to match against this, this, and this, and this, and this, and two more things, the black and the green. And then all of these become hash tokens. Okay, so now when we run all of our lexer tests, we should get a pass. And we do. So now let's go into our parser, because there is one thing we just broke with our parser. We broke our ID selector. So instead of just matching on the hash, what I'm going to do, because now the hash and the identifier are the same token, I'm going to move the grabbing the identifier out before the hash, and then I'm going to delete the match ident. So at this point, everything except for still our color test shouldn't pass, but everything else should pass. Well, remember how the hash includes the hash symbol at the beginning of the string?
Mm-hmm.
I'm going to go ahead and add a substring 1 to that. So we skip over it. And now everything should pass, except for the colors. And that weird one, which I'll look at later. Okay. So now we can go into our parser and actually add code that will match against hashes and turn them into numbers. And that code is actually given incredibly simple because now it's all just one thing. So we'll do case hash, and we'll say go to say values add new color value dot from hash pass in next token dot text, and then skip over the hash, and then do a break. So now we have to go ahead and implement the from hash method, and once that is implemented, we should be good. I'm going to go ahead and bring this guy up to our other guy right there. So getting a color from a hash value is actually pretty straightforward. And it's not going to return an I value, it's going to return a color value, of course. The first thing we're going to do is we're going to say if the text passed in, which I'm going to call a hash, passed in starts with a hash, we're going to strip it out. So hash equals hash dot substring 1. This is actually a string parameter, not a character parameter. Okay, then we're going to say if or var vals, if hash, what am I doing? Equals 3, which means we are parsing like 000, for example. Then go ahead and get our new string vals. Why do I have value just stuck in my head right now? RGB. And this overload of string is cool. I don't know if a lot of people know about it. It takes in a character and a count that's going to repeat the character for. And that's because in CSS, this is equivalent to that, or this is equivalent to that. So we want to go ahead and repeat these characters twice for every one. Then we want to go ahead and return a new color value, and we're going to convert to int32 R with a base of 16. So if you ever knew about this, this is a very convenient little overload that allows you to specify the base, which is 2, 8, 10, or 16 from a string. So that's very nice. And then we're going to do that for all of our other components. RGB, and because this style of color does not support the alpha channel, we're just going to pass in 255. Now, otherwise, if our hash's length is 6, then we are basically doing this just without, we're going to be concatenating each, like 0 and 1 together to, see, the first part is red, the second part is blue, and the third part, or green. Oh no, did I get myself mixed up? RPG. That's what happens. It's like when you say a word so many times, it starts to sound funny.
Right.
When you say RGB so many times, it's RGB. 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 Okay. Okay, so those are our components, and each one of these are 2 characters. Those 2 characters need to be assembled into 2 nibbles, and those nibbles need to be converted into int32s using the base 16. So we'll start off with r equals, and there it is again. Okay, so there is a problem with characters, and that's when you add them together, you get an int. And I think that's stupid. So what I'm going to do is I'm just going to append an empty string to it, and now this is a string, as you can barely see right there.
Mm-hmm.
A second ago was an int, so I'm forcing its hand.
Right, right.
Alrighty, and then basically we're doing the exact same thing, which I probably could refactor this code out to be a little bit cleaner, but I just want to see our test pass. Okay, so now given all of this, we get success.
Nice. Very good.
So now we have to figure out why this test is failing now. So let's go ahead and do that real fast. It really doesn't like the input's chopped off. I hate it when it does that. Or the output's chopped off. Okay, expected. Found solid black. Found. What? That's just stupid. Let's go ahead and debug this and see what comes up. Okay, so our action that we got is returning out a color. Good. So 000255. The action that we're expecting is going to be solid black. Ah, yes. I know why. It's because of my code. I expect an identifier black instead of a number black.
Ah.
Or a color black.
Right, right.
Now I need just to figure out where that is. There it is. So instead of that, I'm going to say, actually, I'm just going to do color value dot from name black. How many parentheses do I have? Maybe more than. See, I can't do this resolution. There we go. Okay, so let's throw in a few more things into our, given lots of stuff test. Let's throw ahead and go throw in a color of red, a background of blue, and a border color of RGBA 111255 or 123255. So now let's add the border color, which is going to be right here. We're going to do r.property border color with a new color value of 123255, 123255. Those were supposed to be commas, not periods.
I was wondering about that.
It's just a little bit off. They look similar.
Okay.
Stuff needs blue on his background. Color value from name blue. And we need a color of red on our li selector or li rule. So our property color, new color value, and then 255.00255. Alrighty, let's see what happens when we run all of our tests. It's still doing that weird thing. I don't know why it does that. Okay, we have one failing test. Could not parse value from token C curly. And let's see about where that failed. That failed next, right after the width, because I don't have a semi. So let's go ahead and run this. And we have green all across the board.
Very nice.
So yeah, that about wraps up all the functionality. I mean, this isn't CSS in its entirety. There are some things that CSS supports that CGS doesn't have a need to support. And there are things about CGS that we haven't done here, like nested rules and stuff like that. But this is a pretty good subset of CSS, and it shouldn't be that much more difficult adding more CSS functionality if what you wanted was a CSS parser.
Right. Awesome. Well, very cool. In the next video, we'll go ahead and do a recap over this whole thing. Now that we've got all of the tests passing, everything's been implemented. And then that'll wrap it up, and we'll be able to move on from there into Antler. So thank you guys very much, and we will see you in the next video for those of you that need the recap.